Alright guys, today we are going to talk about compound inequalities in general. So that's addressing both and or inequalities. So it says solve each of the following compound inequalities, graph your answer on the number line, and write it in set builder notation. So just a quick refresher, and inequalities are where we overlap. We want where the two graphs are overlapping, or inequalities are when we want to graph both of our graphs. So on number 1, I have 2x plus 12 is greater than 6 and negative 5x plus 3 is greater than negative 17. So we want to solve each of these inequalities individually. So I'm going to start with my left one by subtracting 12 from each side. And that's going to leave me with 2x is greater than negative 6. Then I want to divide each term by 2. And I'm going to have x is greater than negative 3. Now let's come over to my second one here, and I'm going to solve this guy by subtracting 3 from each side. And I'm left with negative 5x is greater than negative 20. Then I'm going to divide each term by negative 5. And x, when I divide by a negative, it switches the symbol, is less than 4. Next, what I want to do is just graph my helper graphs here. So x is greater than negative 3, so it's going to be an open dot with an arrow going to the right. And then x is less than 4, so that's going to be an open dot with an arrow going to the left. Now to get our final graph, we need to look at what kind of inequality we're dealing with. And here we're dealing with an and inequality. And is where the two graphs overlap. So I want where they start overlapping at negative 3. And where they stop overlapping at positive 4, and we're going to fill in between. And then finally we need to write our answer in set builder notation. So we're going to have the set of all x's such that, and since this has a starting point and a stopping point, we need to write it as a nice little compacted inequality. So we're going to start with negative 3, we ended with positive 4, our variable x is in the middle. And then to determine the signs, remember your symbols always have to point left with these types of inequalities. If it's an open dot, it's going to be less than, open dot, less than. So we have the set of all x's such that x is greater than negative 3 and x is less than 4. On number 2, again, we have two separate inequalities. Let's go ahead and solve each of them individually. So 3x minus 2 is less than or equal to 13. I'm going to add 2 to each side. And I'm going to be left with 3x is less than or equal to 15. I'm going to divide each term by 3, and I'm going to be x is less than or equal to 5. On my second inequality, 5x plus 3 is greater than or equal to 43. I'm going to subtract 3 from each side, and I'm left with 5x is greater than or equal to 40. I'm going to divide each term by 5, and I'm going to be left with x is greater than or equal to 8. Now again, so far, like the two problems are almost exactly the same, we're going to graph our helper graph. So x is less than or equal to 5. That's going to be a closed dot over 5 with an arrow going to the left. And x is greater than or equal to 8. That's going to be a closed dot over 8 with an arrow going to the right. Now, so far, up until this point, and or inequalities are pretty much the exact same. Now we need to look at what word we're working with to figure out how to graph the final graph. So since this is an or inequality, I want to graph both of the graphs on my final one. So I'm going to bring this red guy straight down, and then I'm going to bring this green guy straight down. Okay. Then, since we have a gap, that means the actual word or has to be in our set builder notation. So we're going to have the set of all x's such that, and then we describe each part of the graph. So this first part here is just x is less than or equal to 5. The gap means we write the word or, and this part here is x is greater than or equal to 8. So that's what we're going to be doing today. We're just going to be practicing the difference between and or, and or. And is where they overlap, or is graph both of them together. So if we go to number 3, I have 3x minus 5 is greater than or equal to negative 17, and negative 2x plus 12 is greater than or equal to 24. So I want to solve each of these inequalities individually. Here's what I'd like you to do. Pause the video and solve those inequalities on your own. Then come back and we'll graph them together. hopefully, when you solve number 3, the first one, you get x is greater than or equal to 4. In the second one, when we divide by a negative, remember the symbol switches, and it's x is less than or equal to negative 6. Now, let's start by graphing our helper graphs. So, x is greater than or equal to negative 4 is going to be a closed dot over negative 4 with an arrow going to the right. And x is less than or equal to negative 6 is going to be a closed dot over negative 6 with an arrow going to the left. Now, to get our final graph, we need to look at the word that we have in between. The word that we have in between is and. So, and means I want where the graphs intersect or overlap. And neither of these graphs overlap one another because it's less than negative 6 and greater than negative 4. Since they don't overlap, we can't have a final graph, which means that our final graph and final answer is no solution. We can't have a number that's smaller than negative 6 and bigger than negative 4 at the same time. Let's go again on number 4. On number 4, we need to solve each inequality first. So I have 2 times the quantity of 5x minus 3 is greater than 44. So let's start by distributing. So I have 10x minus 6 is greater than 44. Then I can add 6 to each side. And I'm going to be left with 10x is greater than 50. Divide each term by 10, not by 5, by 10. And I'm going to be left with x is greater than 5. Now, my second guy, remember we want all of our variables on the left side and all of our constants on the right side. So I'm going to subtract 3x from each side to move the variables to the left side. And I'm going to be left with 2x plus 27 is greater than 43. Then I can subtract 27 from each side. And I'm going to be left with 2x is greater than, now 43 minus 27 is going to give me 16. Divide each term by 2, and we're going to have x is greater than 8. Now I can graph my helper graph. So x is greater than 5, that's going to be an open dot over 5 with an arrow going to the right. And x is greater than 8 is going to be an open dot on 8 with an arrow to the right. Now, before we can graph our final graph, we need to look at what word we have. Here we have an and inequality, which means I want where my two graphs overlap. Now, if they overlap, that's where they start on top of each other and end. So, if I look at my two graphs, they start being on top of each other at positive 8 with an open dot. And if I follow them, notice the arrows are going the same direction, which means that I'm going to end with an arrow going in that same direction. So I'm going to have an arrow going to the right. Now to write our final answer in set builder notation, set of all x's such that, and I want to describe my graph. Now my graph has an open dot on 8 with an arrow going to the right. That means I can use all of these numbers out here, and all of these numbers out here are bigger than 8. So x is greater than 8. Number 5. I would like you to pause the video and solve both inequalities for number 5 on your own, then come back and we'll graph it together. Alright, so when you solve both inequalities, your first one should give you x is less than negative 2, and your second one should give you x is less than 4. Now let's go ahead and graph our helper graph. So x is less than negative 2, that's going to be an open dot with an arrow going to the left. X is less than 4, that's going to be an open dot with an arrow going to the left. Now before we graph our final graph, let's see what word we're looking for. We're looking for the word or, which means I want to graph both graphs together. So if I were to graph my red graph, that's going to be an open dot on 4 with an arrow going to the left. Then if I were to graph my purple graph, that's going to be an open dot on negative 2. But if you notice, the line goes straight through that open dot, so it technically fills that dot and makes it a closed dot. So the arrow also goes the same direction. So since they go the same direction, when we put them together, the red one overtakes the purple one, and we end up with our long graph here. Now it's going to be x is less than 4. Now if we can compare number 4 and number 5 quick, on number 4, notice that the arrows went the same direction and it was an and inequality. And on number 4, the arrows still went the same direction, but it was an or inequality. When that happens and it's an and inequality, you are going to end up with the smaller of the two graphs. When your arrows go the same direction and it's an and, your final graph will look like the smaller one. When the arrows are going the same direction and it looks like an or inequality, your final graph is going to look like the larger one. So that's kind of a little helpful hint that you can use in the future. On number 6, notice how our inequality is already compacted. When that happens, just remember this is an and inequality. Okay, that is how they how they can rewrite an and inequality. Now let's solve for x here by getting x all by itself. So first we're going to subtract 6. But remember, when it's like this, we have two inequality symbols. So I'm going to subtract 6 from each side. So I'm going to subtract it from 18 as well, and so same with 24. Now if I take 18 minus 6, I'm going to be left with 12. Bring down my inequality symbol. These 6's will cancel out and leave me with 2x. Bring down my inequality symbol, and 24 minus 6 is 16. Now to get x by itself, I need to divide each term by 2, and 12 divided by 2 is 6x, and 8. Now, when your inequality is written like this, remember you don't have to do the helper graphs. We can bring it straight down. So it starts at a 6 and it ends with an 8. And if we look at the symbols, my first dot's going to be closed, my second dot's going to be closed. So I want a closed dot on 6 and a closed dot on 8, and we can fill in between. Now finally, to write it in set builder notation, we're going to have this set of all x's such that, and we can bring this guy straight down. 6 and 8. Alright, on number 7, we have 2x minus 1 is greater than or equal to 13. Notice, guys, we don't have the word and or because this isn't a compound inequality. This is just one inequality. So let's go ahead and solve it. So I'm going to add 1 to each side, and I'm going to be left with 2x is greater than or equal to 14. Divide each term by 2, and I'm left with x is greater than or equal to 7. Now we don't have to do a helper graph because, again, it's just one inequality. We can put it right on the line. So greater than or equal to 7 is going to be a closed dot on 7 with an arrow going to the right. And we can say that's the set of all x's such that x is greater than or equal to 7. Alright, on number 8, I would like you to pause the video and do the entire problem on your own. Okay, hopefully when you solve the first one, you get x is greater than or equal to 2, and the second one, x is less than or equal to 0. You graph your helper graphs and notice that this is an or inequality, so we bring them both straight down, and we're left with the set of all x's such that x is less than or equal to 0, or x is greater than or equal to 2. Alright, let's do that again on number 9. Go ahead and pause the video and solve number 9 on your own. Alright, hopefully you solved and got x is greater than or equal to 8 and x is less than 6. Since this is an or inequality, we want to graph them both straight onto our graph, which gives us a set of all x's such that x is less than 6 or x is greater than or equal to 8. Alright, go ahead and try that again. Pause the video and solve number 10 on your own. Okay, so when we add 6 to each side and divide each term by 3, we get negative 3 less than x less than or equal to 2, which gives me an open dot on negative 3, a closed dot on 2, and filled in between, and the set of all x's such that x is greater than negative 3 and x is less than or equal to 2. On number 11, again, pause the video, try this on your own. Don't forget, you want all of the variables on the left side and all of the constants onto the right. Okay, so when you solve your first inequality, you should get x is greater than or equal to negative 1, which is a closed dot and an arrow going to the right. And our second inequality is x is less than or equal to negative 7, and that's a closed dot with an arrow going to the left. So since this is an or inequality, We bring them both straight down, and we have the set of all x's such that x is less than or equal to negative 7, or x is greater than or equal to negative 1. Finally, pause the video and do number 12 on your own. Okay, when you solve your first inequality, you should get x is greater than negative 4, and that's an open dot with an arrow going to the right. And our second inequality is x is less than or equal to 2, which is a closed dot with an arrow going to the left. Since this is an and inequality, I want where these two graphs overlap. They start overlapping at negative 4, and they stop overlapping at 2, so it's an open dot on negative 4, closed dot on 2, and filled in between. Finally, we have the set of all x's such that x is greater than negative 4 and x is less than or equal to 2.